Hello friends, I welcome you all to my YouTube channel. So in this discussion, I want us to look at this problem that is presented before us. So this problem that we have has four parts, that is A, B, C, and D. And this is what we're told to find the derivative of each of these that is here. Okay, now we'll start with A. So, before we look at this one, let us first identify the nature of these functions that are here. So these functions are all having powers. These are algebraic functions, all having powers. So it means that if you are to find the derivative, you are simply going to use the power rule. So to evaluate all these, to evaluate them, like by finding their derivatives, we are simply going to use the power rule. Now this is the way the power rule is. So if let's say we have our function y, which is equal to x raised to the power n, like that, where n is a power, this is a constant, x is a variable, where y is defined in terms of. So to find dy dx, we're going to simply have something like our dy dx will be equal to. So the n will drop to multiply with the x. Then while there's n there, we'll write the same n but subtract the 1. So this is the method that we're going to use to evaluate these functions that are presented before us. So let us now come to A. So A is y, which is equal to 20 minus 1 over 3 x to the power 4 plus 10x. But one thing that we need to know is that the derivative of any constant is simply set to be 0. Okay, so mean that differentiating 20 will simply give us a 0. So we can say dy over dx is equal to, so let's differentiate this one. Differentiating 20 we get a 0 minus, so here the 4 will come and multiply with the 1 over 3. So I have 4 multiplied by 1 over 3. Then what we do is we'll get the 4. Now before that we'll say x the power 4 minus 1 according to this method here. Then say plus. Now this x raised to the power 1, so it will be 1 multiplied with 10, then x to the power 1 minus 1. You always subtract 1. So this further gives us 0 minus, so this will be 4 multiplied by 1 over 3, which gives us a negative because of this 0 here. So we get negative 4 over 3 x to the power 4 minus 1 gives us a 3, then plus. So this will give us x to the power 0, which is the 1, and 1 times 10 just gives us a 10. So this is our answer to this problem, the first one. Now let us go to B. So B is like this. What we have, y which is equal to 5x minus x over the root of x plus 4 over 5x squared as our function. Now let us evaluate its derivative. So dy over dx will simply be equal to, so 5x, the one will come and multiply there, so you are just going to remain 5. Then before we come to the derivative, let's first simplify this further. Well, we have y which is equal to, this is 5x minus, this is x, then this which is down here is the same as saying x to the power half, then say plus, this one is 4 over 5, then we can take the x squared that where 4 is, now this will be the power negative 2. This is according to the rules of indices. Further simplifying this, we get y which is equal to 5x. Now this one here can be evaluated. Now since we have the basis to be the same, we can subtract the exponents. Now here we have an exponent of 1. So 1 minus half will give us half. So we have 1 minus x to the power half plus 4 over 5 x to the power negative 2, like that. Okay, now this is now what we can use to find our dy dx. So this gives us our dy dx to be equal to, so 5x is the same as upon differentiating to just remove the 5 minus the half will drop to multiply with x. Then we say half minus 1 then plus 4 over 5 x to the power negative 2, subtract the 1 there. So we further simplify this by saying 5 minus half x. So we say half minus 1. This will simply give us a negative half. Yeah, negative half. Then plus 4 over 5 x to the power negative 2 minus 1 gives us negative 3. Like that. So this can be simplified further where we avoid the negative exponent. So to do this, we're going to drop the variables with their exponents. But in this case, the negative sign will cancel, leaving us only with a positive exponent. So we have 5 minus 1 over 2. So this will come 1 to each. So we're going to have x to the power half m plus 4 over 5, then the x to the power 3. Now this one can be simplified further. We're going to say this will be equal to 5 minus 1 over 2 x squared. Then we say plus 4 over 5 x to the power 3. So this is the answer to our second problem. So this is how we differentiate the second one. Now we'll go to C. So for C we have that our function y is equal to 8 root of x plus 3 x to the power negative 5 plus x over 2. Okay, so this is the same as simplifying it as y, which is equal to 8x to the power half according to the rules of indices, then plus this one will leave it the way it is for now, 3x to the power negative 5 plus, so this x over 2 is the same as saying half multiplying with x. Okay, let us find the derivative of this function y. We'll say dy over dx will be equal to, so the half will drop, so we're going to have half multiplying with 8, then say x to the power half minus 1 plus the negative 5 will drop, multiply with the 3, then you have x to the power negative 5 minus 1. Now this one, since we have 1 there, when the 1 drops here and the 1 subtracts the 1, we're just going to remain with a constant half there. Okay, so further simplifying this, we're going to get, so the 2 and the 8 will divide, leaving us with 4 x to the power. Now half minus 1 gives us a negative half. Now this is positive and negative, get a negative 5. No, sorry, 5 by 3, which simply gives us a 15. So I have negative 15 there. X to the power negative 5 minus 1. This gives us negative 6 plus half. Okay, so we have something like 4. Okay, so we can say 4 over x to the power half, because we've gotten rid of the negative exponent, minus 15 over x to the power 6 plus half. From there we get 4 over x square root minus 15 over x to the power 6 plus half as our derivative for the third problem. Okay, we now go to the last part, which is D of this question. This is y, which is equal to x over square root of x to the power 3 minus 2 over x multiplying with x root of x to the power 3 plus 1 over 3 x to the power 3. So this one, the same as saying y is equal to x over x to the power 3 over 2 minus 2 over x. This one is same also as x to the power 3 over 2 plus 1 over 3 x to the power 3, like that. So when we apply indices, evaluating this one will give us, so we have y, which is equal to, so this one just gives us x to the power negative half, like that. Then minus this one will give us, when we, since these are some bases are going to just have 2 x to the power half plus 1 over 3. This one we drop the way it is for now. So what we do next is we're going to bring this the other side, so it will be negative half divided by x to the power negative half minus 1, then minus half to multiply with the 2, say half minus 1. Then we say plus the 3 will come and multiply with the 1 over 3, then say x to the power 3 of minus 1. Okay, now negative half minus 1 gives us negative 3 over 2, so we'll get negative 1 over 2 x to the power negative 3 over 2 minus, so the 2 and the 2 cancel, leaving us with a negative, sorry, there's x here, leaving us with negative x the power negative half. When we say half minus 1, then we say plus, so the 3 and the 3 will cancel, leaving us only with x to the power 3 minus 1 gives us a 2. Okay, so this is same as saying negative 1 over 2 x to the power 3 over 2 minus 1 over x to the power half plus x squared. So this is same as saying negative 1 to 2, there we can say square root of x to the power 3 there minus 1 over the square root of x according to indices, and we say plus x squared. So this is our answer. Now be mindful that this is a 2, okay, which is 1 point the square root of x cubed. So this is our answer to the fourth problem. Please make sure to go through this and share the video, please, and also don't forget to subscribe to our YouTube channel. Thank you very much.